All right. We're going to talk today about unifying vector and keyword search for enhanced LLM performance. All right. So the key of this is something called hybrid search, and we'll learn all about it. You'll probably know at the end of the session more about this than I did, at least before the prep with Ohad. Just a quick mention, I did share the link in the comments, but please introduce yourself, ask questions, so forth on the Discord of LLMOps.Space, not over here in the general chat. About a bit about the community. So the community focuses on content, discussions, and so forth, and events. A lot of our focus is on events and topics relating to deploying LLMs in production. What's really cool about this is I think there are a lot of communities that have great content, but also other content, and we try to focus solely on this. We also aim for mid-level and senior practitioners and try not to have too much of a, let's call it a confusion between the different levels, and we think it's content that's also great for people earlier on, even if they can't catch every single phrase. So a bit of the updates in the LLMOps space from this past couple of weeks. So Meta released Llama 3, which I think a lot of us were waiting for. I think the comparisons with both Llama 2 and things like GPT-4 aren't yet thorough, but it does seem like it's big news already now. And it's not only like heavier and better, but there are also some inherent improvements. Microsoft released 5.3, which is basically, if you dive into the family of the 5.3 models, there are a lot of advantages where they outperform some of the larger models. I think what's really weird and interesting about this space is every announcement says it performs very, very good compared to its size. For me, it's a little hard to keep track, and also to me, it reminds at least of kind of boxing matches where you have weight categories that are like of 2 pounds different or 2 kilograms, and then and the champion for that weight. So I think there are some of these issues, but I think it does seem like it's a major. It's also a major release, but again, a lot of these times you really only know the news once the thorough comparisons happen a while later. Something that's much more concrete is a major acquisition of Run AI. Run AI, I know the CEO on personal terms, and they were acquired by NVIDIA for a significant sum. These numbers are never accurate, but the area is 700 million, which is a significant acquisition. There are a few blogs about why it was such a strategic acquisition for NVIDIA. I think it's really interesting, where basically it helps you do better with your GPUs, and it's supposed to help NVIDIA sell their heavier or higher end machines. And Cohere released a significant paper, which I do think that the idea existed, but it's formalizing it, where basically it's instead of LLM as a judge, it's kind of a jury, where you have something called a poll, which is a mixture basically of different LLMs that are all acting within the LLM as a judge. So these are all updates about the space. We're working now on the next version of the mapping of products and companies. So if any, either you or any of your colleagues are working on a product related to the space, then definitely we should add it. So reach out to one of the admins, or there's a form also on the website that you can fill out. And yeah, we're also expanding the consultant list that we have on the website, where we try to give details that enable you to know exactly what you need for actually working with them. And new and exciting news is we're working on a new website. Anyone that was in our website, the LLMOps.Space website, I think has great resources, but it looks kind of like Notion, so it's going to look better soon. So we're working on this in the background, and that's it about general about the community. Let's talk a bit about the agenda for today. So we're going to talk about, keyword vector search, how it integrates within your workflows, about metadata filtering, aggregations, and something I think many of you have heard before in the context of general NLP, which is ranking based on TF-IDF, but we'll see it in a more concrete context of search, and some vector search algorithms, including KNN, et cetera, et cetera. So a bit about the speakers. So first of all, yours truly, myself. If you watched the previous videos, you must be sick of my voice, but I'm the moderator here at LLMOps.Space and also co-founder CEO of DeepChecks, where most of my time is spent on continuous validation or continuous evaluation of LLMs and also other types of AI. It's still hard for me to say that word, even though a lot of time has passed since it's been re-legitimized. about Ohad a bit. So Ohad is an entrepreneur working in the space of data, product strategy, and so forth for 15 years at both large corporates and startups. He co-founded Hyperspace to solve some of the most burning issues that he saw related to real-time search. I think what's cool about search, we'll learn today, it was never like a boring, cold kind of side subject, right? Even before the new hype of vector search, were some great companies that are kind of based on it. And now it's like it's pulling fuel into fire that already exists. So we'll learn more about the bits and bytes of it today, but I think it's a topic that's always relevant. It's one of the topics that improving it by a bit can sometimes make a big difference. So again, this is one session. We have sessions every couple of weeks. So if you or your colleagues or just other great speakers you met in the past want to speak in this series of meetups, then let us know. There's a form here to apply. You can also reach out to one of the admins in the Discord, and that's it. So Ohad, you're up.
Thank you so much, Philip, for this great intro. Happy to be here. Really excited about this great community that you've established.
Amazing. Thank you so much.
All right. Can you see my screen?
Still says loading. Now we see it.
Okay. So we're going to talk about search. We're going to talk about hybrid search and the way that unifying vector and keyword search in one solution or one holistic solution can really enhance LLM performance in RAG applications and in other use cases. A few words about myself, as you already mentioned. I'm Ohad. I'm a co-founder, CEO of Hyperspace. Throughout my career, I worked at large global corporates such as Intel and HP, and then moving into smaller and smaller startups. Basically, I'm a data and AI person, but I'm doing it as a product person in my DNA. And 2.5 years ago, I started Hyperspace to build the world's fastest search engine. So just maybe 60 seconds about us and what we do. Our vision is to build one database that can treat any type of search, either classic or vector, for any kind of scale, for any kind of use case, real-time or offline. The top verticals that we are working at are obviously Gen AI, LLMs, e-commerce recommendation systems, and obviously fraud, which is really sensitive to latency. In terms of product, we come to resolve this distinction between vector and classic and have an ensemble of those functions in one place. And the kind of breakthrough that we deliver in terms of technology is that we actually design and program a dedicated chip for search. And by doing so, we can provide a step function in performance, scalability, and cost effectiveness. So this is a little bit about us. The rest of the presentation would be on the chosen topic.
Wait, just 1 second. As you're starting here, I'll launch the first survey. So I'll just say the survey out loud. You should each have it on your screens. What's the current development stage of your LLM-based application? So I know this search is a bit different, right? Because it's a technology that's both for the classic kind of chatbot LLM type use cases, and also if you need a ranking at the end. So it's really special, but still it's worth asking. So the phases that you could possibly answer are conceptualization and design, development and testing, production and deployment, and optimization and scaling. So these are like, I see it like almost as a journey between them, different phases. So let's take this for a while, do maybe one more slide, and then I'll come back and show the results here, and we'll continue from there.
Sounds good. Sounds good. Philip, I like the concept. Keep interrupting me as much as you can.
That's what we're here. It's our specialty here in Israel to interrupt people.
Exactly. Okay, so I think, as you said in the beginning, search is not new. Undoubtedly, search and vector databases has become a fundamental piece within the LLM tech stack. It's been here for many years now, and there are lots of databases and features that highly matured in this area. So if I kind of try to simplify things, And on the right side, I'm looking on vector search and vector databases. This is a super hyped area with at least 10 providers right now in the providing vector databases. But in terms of adoption, specifically in production, the adoption is still low. And we are still in the early days of that. If we're looking on classic search or keyword search, others may call it lexical search, the adoption is significant. I think there is every e-commerce site in the world is using classic search, and probably most of the recommendation systems and many other verticals are actually built upon a search application and search database. The hype is a bit smaller, and those are using established products like Elasticsearch, Solar, and AWS OpenSearch. So what are we going to talk today? We're going to talk about everything in between those two pillars, right? We're going to first do a quick recap about vector search, why it's great, but we will also look on why it's not perfect and what is still missing over there, and what you can do to get it into the next level. Then we quickly go over a keyword-based classic search. I'm going to do a very nice summary about all the history and what you can have from there, at least the main stuff that you can use. And then we're going to talk about hybrid search and how those two functionalities and two things can be merged together, and how you can enjoy the best of both worlds.
Okay, great. Now I'll share the results of the poll. So here we have for this poll, so conceptualization and design is 43%, development and testing is 39%, production and deployment 11%, and optimization and scaling is 7%. Actually, I think it's really interesting because this is a pretty advanced topic. So you think a lot of people will be at the scaling, this and that, but a lot of them are at conceptualization, design, and development and testing. I think a part of it is that some of the people here, the journey actually already are using search or interested in search for one use case and expanding to other use cases, which is, I think it's like an anomaly within the topics of LLMOps.Space, but doesn't matter. It's the same material and important to anyone that needs either vector database or vector search or similar technologies that give you the same type of functionality.
I actually think it's proved the statement here about adoption of vector search, but anyway, let's start. So search is being used in many different use cases, also in RAG and other. But I want to start with a very intuitive example just to illustrate what hybrid search means. So taking an example from a movie recommendation system, let's think about the movie Kung Fu Panda. I'm trying to find similar movies that maybe my kids would like. And I want to use the description of the movie in order to find similar other movies that my kids might like.
That's why you put bamboo on your background, right? Okay.
Exactly. So let's assume I'm using vector search. I'm gonna embed this description using either large language models or any other language model. And then I'm gonna run a simple vector search, KNN search, and try and find the top K that match to this description. And I'm getting, as requested, the top 8 results. Now, if you look on those results very carefully, you might see Enter the Dragon on the left, on the third pick, because in the description we see Dragon Warrior being described, and obviously those, and as well as Karate Kid, are not a children's movie. Okay. Which means I didn't get the most relevant and accurate and expected result. So keeping it simple, what I can do in terms of hybrid search is I can put some level of business logic and actually filter the entire data set into a subset of data set. What I can do now is that I can filter by genre. Okay, so if the genre is kids or animation, I can filter the entire data set of movies and then only run the vector search on the subset of data. So using the same description, but only for kids and animation movies. And the other condition that I put here is that it won't match the title because I don't want to recommend the same movie. So over here, once I did the hybrid approach, I get much better results that combine the semantics of the description as well as some business logic. Okay, so the core of every search is similarity and relevance. Even in RAG system or LLM system, I'm running over the vector database and I'm trying to retrieve the most relevant results or the most similar ones to the object or query object that's being searched for. So let's start about vector search, just for the few of you that maybe don't know it yet. A vector search is an approach that's designed for unstructured data. Unstructured data such as videos, images, and obviously free text. The way that we can search across this kind of unstructured data and find for similar objects is that we use encoders to transform the object into a vector. A vector is a series of numbers representing the object in a multi-dimensional space. And after this step called embedding, I take the embeddings, and obviously we cannot imagine a multi-dimensional space, so let's put it on a cube, and then vector search algorithms such as k-nearest neighbors are able to find the distance between those two objects. And this is pretty powerful. It's pretty powerful because vector search captures semantics. And in this way, it captures the context that this question or this word or this sentence has been searched for. It's also highly versatile because it can be used on a variety of objects, from text to images. There are also multimodals that can actually use text to find images. And it's also quite effective for fuzzy searching. So vector search, as its nature of capturing semantics, doesn't require exact match. You can relax the search and run it and get some more results that are similar to what we are looking for.
I think what's cool about the fuzzy search example is or why it's interesting. So anyone that started off with like doing cool hackathon type demos, early on when you're using these regexes to find something. So I don't know, you get someone's text out of their WhatsApp and you do something, that pulls it and shows whatever, and then you want to show an example. So anytime like something goes really wrong in a demo, then it's when you have like, oh yeah, but tiger is very different than leopard, but like it meant the exact same thing. So I think this is part of why vector search I think is so popular. It kind of sits better with intuition, at least when the embeddings are good. Like there was a while when it was like a cool concept when you had this this whole thing of people used to show off that king plus female minus male equals queen is or I don't know, it was the same thing I think with eBay, right? Like eBay minus USA plus China equals AliExpress, whatever. So it was cool examples, but it didn't really work. But now that like the embeddings are good, then it really feels intuitive in a lot of cases, which I think is really special.
Exactly, it's simple, it's intuitive, and it makes a lot of sense. But yet again, it's not perfect, right? And now I think in the evolution of adopting a new technology, now we are trying to take something cool and make it useful in production and make it useful in real world use cases, right? And we need to take it one step further. So maybe just one intuitive example of why it's not perfect, or a few challenges that we have around vector search. So first of all, it's not explainable. In many applications, you need to explain the user why you picked that result. So it's not explainable. It doesn't allow you to add some business logic into that. Maybe you want to filter by a business unit or by a country. So you don't have any control of the results that you're getting. I'm not sure if the use of word hallucinations here is right, but basically, in essence, it sometimes hallucinates because vector search always bring the top K results. If your top K is bring me the top 10, you will always get the top 10. Even if none of the results are relevant in any way, vector search will keep relaxing the search until top K will be found. And those can sometimes be quite irrelevant, okay? So you need to be careful while using just vector search. You need to put some boundaries into that. And intuitive example for that
just to like a quick nuance about the last one. Again, I think sometimes when you bet with your friends, how do you spell a word like this way or that way? So like you can search Google and you can see there are 30,000 results for this one and only 3,000 results for that one. So you know that the correct spelling is the first one. So like that whole area, and sometimes you see no results found, so you understand like a sentence doesn't exist. That whole like area of search is like not relevant for vector search, right? Like it's not that you can't do it with vector search, but it's a pain in the pain in the behind to do it.
I think actually vector search is a great tool to resolve this problem of no results. Because maybe in a second we will talk about classic search. This is the main problem with classic search, which is highly accurate if you're looking for something very specific. But if if you don't have an exact match, you get with zero results, which is quite frustrating. So many use cases today actually build vector search after the classic search, get no results, because it allows to relax the search and get more results. This is a nice example that I like presenting of, let's say somebody is searching for Pfizer drugs for depression, okay? So we got the word Pfizer over there, and vector search, if it relaxes enough the results, you might get Lipitor as a reply for that, which is actually an anti-cholesterol treatment, nothing related to depression, okay? So be careful when you use vector search. It's may be tricky when exact match is needed, and in cases that are dealing with healthcare or medicine and stuff like that. Okay, now let's talk about hybrid search. And I want to start talking in the context of metadata filtering, okay? So what kind of data do we have? So I think up until now, most of the data that was being used up until 2 years ago, the majority of data that was used in the world was structured data, organized in tables, in databases, such as relational databases and data warehouses. But now in the last 2 years, especially in the last year, we see a big boom of unstructured data. Text is now much more usable, free text. Images are much more usable because right now we have the tools to properly use them. And the fact that data is growing exponentially, creating lots of opportunities, but also challenges. So the first kind of topic I want to kind of drill down into is the use of vector search plus business logic, okay, to resolve some of the complexities that we discussed before. So let's assume I'm looking for Air Jordan shoes, okay? I can obviously embed this into a vector. And I can also add a metadata into that. I can use metadata of the user, which are searching for that product, and I can use many different attributes as well. And let's assume I have a huge data sets of billions of items. This can be documents, this can be paragraphs, whatever. And now I want to retrieve, to do a data retrieval. One thing I can do is just run a vector search on that. If I'm in billion scale, I will probably run an approximation HNSW. But right now, I want to propose another approach, which actually starts with a step of candidate generation. Okay, I'm using metadata filtering to apply some logic, to apply some business logic, some rules. Maybe I want to filter down the results by specific tenants or specific companies or business units or locations or even specific users. Okay, this allows me to narrow down the search from maybe billions of items down to millions. And now that I get millions, which I know that are relevant, like I remove all the irrelevant results, then I can do some more heavy lifting, scoring into the remaining of the results. And maybe run the vector search only on those millions. I will benefit in latency, I will benefit in costs, and I will definitely benefit on accuracy as well, getting a much more relevant top K. Again, let's view on a quick example of that. So let's assume I want to build a new e-commerce site that is working like ChatGPT. I don't searching for shoes. I'm searching like free text, like in ChatGPT. I'm searching for Air Jordan, men's size 46 with a color twist. And let's assume I took that text, I crunch it a little bit. So right now, proposing a two-step process. Step number one, I'm extracting filters out of this text. It's pretty obvious that I'm looking for a category of shoes. I'm looking for a specific size, and I'm looking for a specific gender. Here in the query, I'm using the terms themselves, but obviously those can come up in strings. And I can use conditions such as and, or not, like Boolean expressions. And then after this candidate generation phase, this is where I can do the distance metrics and run the KNN against. And this is where I will get much more accurate results. Now, considering filtering, there is a big dilemma whether running the filters before the vector search or after the vector search. In the previous example, I presented a use case of pre-filtering. In my opinion, pre-filtering, if possible, will probably deliver better results because I'm using filtering, I'm narrowing down the data set to millions, and then I run KNN, which is a brute force delivering exact match. So the top K would be highly accurate in this case. But in some cases, this is not possible. In some cases, filters cannot narrow down the data set in such a magnitude from billions to millions. Maybe I get 200 million, and 200 million cannot run in fast enough in brute force most accurate and optimal solution. In this case, I would be probably forced to do post-filtering. Post-filtering means that I take the billions, I run the vector search first, probably will do an HNSW, an approximation, because I want it to run fast in real time. And I would probably retrieve a much larger top K, not top 10 or top 30. I would get maybe top 100 or top 1000. And then I will do the filtering afterwards, making sure that I have enough, that I'm getting enough results. This is why you need to pull a bit more. So this is another approach, because using approximation, I guess the results might be a bit less accurate, but some applications can live with that as well. So this is a little bit to give you some insights about the pros and cons of pre-filtering versus post-filtering. Okay,
All right, so there
hmm.
are a couple of comments, questions, and so forth in the Discord. Again, there are a couple of questions also asked here, but I'm referring you to the Discord and prioritizing those questions. So a couple of questions. One of them is Nikki's Mix asked. He said vector search. We might want to mention that it's good. It's just as good as the embedding model and the chunking and so forth, and that the pairing is very important, right? So I would support that. I'm not sure I got 100% what he was referring to, something called the pairing. So it might be the pairing between the chunking and the type of search and so forth. But I think that's true, right? It's not the quality can differ very significantly if you're using a crappy embedding model or a good one. But Ohad, if you have anything else to comment about that, and
Just to agree on that, vector search was here 3-4 years ago. Many companies were using that. I think the big step function was with OpenAI and ChatGPT, where the embedding models have become much more accurate. Obviously, search is just one step in the full process, and having a good embedding model is critical.
All right. Okay. So next question. There's a question by Coder in the Discord. Even after pre-filtering, we get like millions of items. Can we do KNN on millions of items fast enough, or do we still need to use ANN?
Okay. So I can tell you from my experience, and obviously this is something that we are trying to optimize, and at Hyperspace, it's in our core. But from the benchmarks that I know, most vector databases choke around the millions, around the few millions of vectors. So if you need to run over thousands, hundreds of thousands, KNN will probably run perfectly on most vector databases. It might run okay in just a few millions, but if you have more than that, like tens or hundreds of millions, KNN brute force would probably not run fast enough on 100 milliseconds or anything like that. So if you go beyond that, I would recommend using an approximation HNSW. Obviously require to index the data in this way.
Yeah, I think what's really cool here is like it's like, but I don't know if it's your primary point of the talk, but I think it's a really, really important point for LLM practitioners. If you have like 10 paragraphs in your document, a lot of folks say, okay, I don't need vector search for that. Like, right, I can do something a lot more basic. And if I have a billion, then I also can't use vector search, right? Then I need something like hybrid search at least, if not something like keyword search. So there's only a sweet spot in the middle that actually works for vector search, which is why you might have to do techniques like this before and after.
Yeah, I think basically there are a couple of motivations to use this technique. One is to get better relevancy. Okay, I want to narrow down the search because I actually need that from a business logic perspective. And the second is to mitigate latency and performance requirements. Okay.
All right. Okay. A couple of other questions. We'll go a bit faster through them now, just because we're already getting a lot. Jason A is asking, some vector databases include metadata filtering as part of the vector search step. Is this merged approach best? I assume it's just wrapping what you're proposing.
Obviously, my presentation, and Philip, you insisted about it, is not relating to a specific vendor or a specific solution. I'm talking about a flow. Many vector databases already support the ability to filter. Some of them are limited on the number of metadata fields that can be populated. But basically, I'm separating between the database capabilities and what the engineer or the data scientist actually need to program in to get the optimal results.
All right. Okay. All right. Let's do one more for now, and then I'll wait for a bit. Oh wait, actually, I'll do one quick other one before that. Dino asked, can you repeat what were some of the conditions where pre-filtering is not possible or feasible?
Okay. So I said that in my opinion, pre-filtering is always preferred. I think I would use that. I would probably won't be able to use that if that after the candidate generation, I still get too many candidates. Like I get more than like tens of millions that I cannot run KNN on because they won't finish on time, performance-wise. So in my opinion, I will always probably prefer pre-filtering if possible. But in the case that the filter is just narrowing down from billions to hundreds of millions, this won't be possible.
All right. Okay. One last question, which my guess is you won't be able to answer live, but maybe Ohad, you can join the Discord afterwards and kind of take up the questions I didn't manage to get to, but we'll have a couple more later on. So Sana asked, they have a large JSON file in their use case, which can be 15,000 characters. So then they're asking about how to deal with it. My guess is it's too particular and that you need to kind of think about it, right? And so
yeah, and I have a lot of things on the agenda, so we can
okay.
definitely follow up offline.
All right, so for that, Ohad, try to connect with Sana also offline. I raised it because I think it's not that rare, but I think my intuition is that that needs a special kind of treatment. Maybe if the audience were large enough, maybe a designated session, but I don't think it's that big. So anyway, all right. So I think continue for now, but as you continue, all my parting gift from this break, I'll do the next poll. So the next poll, we're just going to ask about vector search. So I'm launching it. The question is have you implemented vector search as part of an LLM-based app? The answers are not yet, yes, in an experimental setting, yes, in a production setting, or yes, in production setting with advanced techniques or experiments like hybrid search or just interesting intuitive things. So answer this. So Ohad, keep on, and we'll stop at a slide or two to see the results.
Okay. So metadata filtering is basic, relatively. And as mentioned, many vector databases already support that. Now let's talk about the next level of classic search, which can really take relevancy to the next level. And this is, let's talk about rarity-based scoring, okay? Rarity-based scoring is a method which exists for years. It started in the mid of the previous century and then been evolved, started by term frequency, TF-IDF, and then moved into a copy BM25, okay? The essence of the algorithm is that it rank or score the word based on its rarity across the corpus. So if we're reviewing the formula, this part is actually response on the rarity. So rare words get higher score. So if I have a data set of billions of items, and I'm searching for an item that appears only a few times, it will get a very high score. If I'm searching across a very popular item, let's say the extension of gmail.com, this is quite rare, the score would be much smaller. Another thing is measuring by repetitions. More repetitions get higher score. And so, and again, this is the TF-IDF scoring, and the BM25 is the way to aggregate those results across multiple words. This method is widely being used in all of the e-commerce sites in the world, in many ranking and classic search functions, and it's highly accurate. Let's view an example of that, and let's move into some strengths and weaknesses of this approach. So a quick example of that, let's look on this query example. I'm starting by setting the score to 0 and setting a boost factor to 1, okay? Then I'm moving into filters that I did before. I want to filter by genre, and I'm going to do an intersect between kids and animation. So everything that I did in the Kung Fu Panda in the beginning is still here. Then I'm going to do a rarity sum for the genres. So I have kids and animation. And in this way, I'm going to summarize the rarity that I got for both. And obviously, kids and animation are not widely spread across the data set. And then if I have a match on language, I can do the same and maybe do an intersect between English and Spanish, and then do a rarity max on language. So I can do, in one case, rarity sum, in other case, rarity max, and just pick the maximum. And in this case, I'm setting the score. In this case, I'm just adding and increasing the score. And then I can move into the next condition. So there is a condition inside a condition. And the next condition is maybe picking movies that rated high, or maybe that are more that been released in the last 100 days or whatever. It's quite flexible, obviously, and you can write your own logic. And in this case, what I can do for those highly ranked movies is that I can add a boost score. So I can do arithmetic manipulations here. I can do a boosting. And so I can take the score here and multiply it by 2 or whatever factor that I find best. So basically, I have a lot of flexibility to build up and define a very versatile score function. So in this case, I assign a score based on matching genres. I increase the score using rarity of matching languages. And then I ended up providing a bonus score for highly rated and long-running movies. Okay. So this is quite basic. Obviously, we are familiar and saw customers using a much more complex logics and score functions than the one presented here.
But still,
just to illustrate.
But still, I think most of the audience, going back to what I said at the beginning, I think most of the audience didn't see this yet. It's very classic, and it's kind of like, how did I not see this 100 times yet? But for me, it was the first time kind of preparing with you to see.
Exactly. So we really try to narrow down some functionality in a very small query. Now, this is classic search. In a couple of slides, I will try to merge them together with vector search. So what's the strengths of this?
Just 1 second. Let's end the poll and share it here for a second. So, so have you implemented the vector search as part of an LLM-based app? Not yet, 27%. Yes, but in an experimental setting. Ooh, interesting. 47%. Yes, in a production setting is 18%. And yes, in let's call it the advanced production setting, 7%. So I think what we speculated at the beginning is right? Like more people dealt here with search than dealt with like the classic RAG, which is cool because it makes sense given the title. But also, search is fundamental for RAG, but a lot of people doing RAG just kind of take what's out there out of the box. They don't need the best performance, and for some cases they do.
Or they are still experimenting or in POC phases. Well, this is very interesting results because I see only 25% in production.
That's
those that are
that's like higher than they said that they have LLM productions for the beginning. So I think that's what I was aiming for. But yeah. So really interesting. But aside from the diagnosis, one more question I wanted to give you from Uri Cohen, who actually also know personally, maybe you also do. Are you also considering the speed optimization algorithms for KNN?
Yes, absolutely. I think so. So the question was about speed and performance, right?
For KNN.
For KNN. So obviously, only 25% of the people in the pool said that they are in production. Once you need to move to production, this is where you face all the scalability and performance challenges that both classic search and vector search introduces. And if the question was about us, about Hyperspace, so the answer is yes. We are trying to optimize all the different functions that presented in this session, either classic search and vector search.
Okay, amazing.
And if I need to explain how, this is another presentation. It will take me some more time to explain how we do it.
But I think what's cool here, a lot of times when people talk about scale or production, it's things that like sound far away. But with search, right away, like boom, you give it to the user, right away they're expecting like quick results and everything. So you can't wait that long. You can't say, yeah, we'll have it kind of slow and flaky for the first year and then we'll think about it. It just is not the right feel for that.
Yeah. I'm just
All right.
minding the time here, and I'm going to speed things up a little bit because there are a couple of more cool examples I want to present you.
All right. Feel free to even skip some slides and so forth because we're approaching wrapping it up.
Okay. So keyword search is fast and accurate, is explainable, and it doesn't require training. Those are the strengths. The weaknesses is that it requires exact match. If I'm looking for tiger, I will only get tigers. And I won't get Panthera tigris, for example. Vector search will do that for me, by the way. So in order to enjoy the best of both worlds, what we can do is that we can combine both scores together. We can take the vector search and the lexical or classic search score and combine them both together. How do we do that? This is the most simple example that we can think about. I'm again starting with some filtering, similar filtering that I did before, match on category, match on size, and match on a brand, or not match brand, just to illustrate that you can also do it as a no match. And then I can take a KNN distance score, and I can take a rarity max coming from the category that we've seen in the example below, and I can put some weights into that. Now, what the big question here is what the weight should be, and it's not so tricky to define. But yet again, this is something that needs to be experimented and explored. But from a functionality perspective, it's doable. It's doable to combine BM20 TF-IDF score with a KNN score in the same score function running on same data set. Okay, and we call that hybrid scoring. Okay, of using both results together. And maybe this is I think it is the last slide and last example that I wanted to share today. Again, taking the same example from before. Let's assume I'm a user searching for Air Jordan men's shoes size 11 with a color twist. What I can do a simple vector search. Okay, I can embed.
I had one question we got from Coder again that I think is inherent to this explanation. He says the combination, he or she, the combination heavily depends on the score distribution of vector search and TF-IDF score. It is actually very tricky. Can you say something? Is it normalized in any way? How do you treat the fact that just the distribution can be very different between them?
Both of them can be normalized to 0 to 1.
Okay, so once you do that, then
but even when they normalized, this is not trivial to define which one to weight better. And I think it's really goes into the intuition, experience, and experimentation of the search architect or the data scientist that needs to build this query. You need to experiment and see which ones get you more results. There are no simple ways to answer, and probably it would be different from a use case to use case. In some cases, you can use multiple vectors and multiple fields for rarity, so it's really case dependent.
Right, but still it's complex, right? Because with the way you normalize, you can impact significantly what's happening here, right? Because if you get it to be uniform 0 to 1 for like all the results, then might like not work well, and you might have I think Kodo is right here that there is an art here, like just intuitively, right? But I think here that also a big part of it is how you do evaluation, right? Because even if you're like a vendor that's giving them the search, the company or whoever's the product owner needs a data set that has like the right rankings or like a way to experiment. Because if they don't know what's considered better, then they also can't help play with the weights or whatever. So it sounds there's a challenge here.
And by the way, it's more challenging in vector search because, as we said before, vector search always provides you the top K. Always. In rarity based, if the score is low, you know that it's low. You know that it is irrelevant.
Right.
but
Right, but
in
still,
vector search is a bit more tricky.
but still, hybrid search, to evaluate hybrid search is probably has the bad characteristics of vector search also, because maybe not 100%, but at least some of them. All right.
Okay. So just let's view one example that summarizes everything again in relatively simple way. So if I'm a user searching for that, we can take the entire text as a query. We can embed it into a vector, and then I might get a variety of Air Jordan products. Okay. But if I use hybrid search, obviously I need to work much harder as a data scientist to generate this kind of query and this kind of logic. But if I can capture that from the text above, that the user is searching for shoes, men's shoes, and the size is 11, and I can combine both results of KNN and the rarity-based scoring, then I can get into a much more higher precision and much more relevant results. Not in all use cases, relevance is so critical, but if it is, this can be a real game changer. Okay, so let's do a quick recap and let's see if we have any more questions. So what we did today, we discussed about vector search and the areas that it kind of fails in, where exact matching is needed, or where business logic is needed, or where performance is challenging to achieve. We did some education about classic search, which is widely being used and established for many years now, and how filters can enhance our queries, and how hybrid scoring capabilities can really take it to the next level. And last thing is to say to everyone using vector search, go hybrid.
Amazing. All right. So just a little recap on my side. So again, if you have similar talks and so forth, feel free to reach out. I think this was a really great, I don't want to say intro. Let's call it kind of giving you things you probably should know by now, but don't know about search. I really like the kind of touching the different areas. And Ohad kind of mentioned that that's what they're focusing on at Hyperspace. So I'm sure Ohad would love it if you reach out with any thoughts or questions and so forth. And please tune in, follow LLMOps.Space on join the Discord, but also follow on LinkedIn, Twitter, and so forth. And that's also a great way to just be notified about the next events. So anyway, pleasure hosting you, pleasure meeting you all from around the world, and hope the discussion continues on Discord. It doesn't stop here.
Thank you, Philip, and continue doing this great job.
Amazing. Thank you so much. Bye.